Champions, welcome to the latest episode of What the Hell Was the Previous Tech Thinking. So we've got here what should be a straightforward, pretty much all the repairs go about the same, give or take, you know, the amount of damage. A Blues Deville. Now this is an original one, not the reissue, so it's got fixed non-adjustable bias. It's been brought in for some horrible sounds, horrible modulation of the guitar signal, and I'll show you why. So you can see down here the typical IC cap splooge coming out the end. It just finds the weakest point, which is the lead entry point, and leaks out. Now this may not even be the failed cap. We'll test the ripple and find out, but often you'll have them actually physically leaking like this, and they're still operating, but not for long. And sometimes they look perfectly fine, and they're completely open circuit, no capacitance at all, or just approaching infinite equivalent series resistance. It's a mouthful. I need another coffee. So that's the primary fault with this amp, and I'll show you what it sounds like, and then we'll go over all the other silly stuff in this amp and all the other things that have been overlooked by the previous tech. Alright, so we're going to fire it up. I've checked it to make sure nothing's going to go on fire, but you never know. So at least I got it on video if something funky does happen. Good for the algorithm and whatnot. So you can hear there, although there's no super obnoxious buzzing, just at idle, there's some noise there, but not what you'd expect given the failure of a B+, so perhaps it's actually the screen node that's failed. However, there is quite a large degree of common mode rejection of power supply noise, just by virtue of the symmetrical nature of the phase inverter and the output stage. So sometimes you can have up to like 90 volts ripple on that line, and nowhere near the dramatic noise you'd expect on the output on the speaker, given that large amount of ripple. So that's the sound you get. It's essentially like a 100 hertz rectified sine wave superimposed over your signal. Sometimes if the caps are still trying to fight for their dear life, it'll be more of a sawtooth type shape. But essentially it's intermodulating with your signal, and it's most obvious when you play up the neck as a horrible, almost like a ring modulator type sound. Alright, so C34, which is the B+ top filter cap, because they're in a totem pole arrangement, you know, series caps. It's actually kind of counterintuitive. You'd assume these two would be in series, but it's actually, this is in series with C35, which is over here. So it goes this one and then that one, the B+ stack, and then C42 and C41 make up the screen node. So measuring the B+, C34 on the positive terminal, we're getting 415 volts. We should be measuring about 470 there. So because there's lack of filtering, the average voltage goes down, and that's what the meter's showing there. Now on the screen node, we're showing about the same. Now let's check for ripple. So on the screen node still, we've got about 385 millivolts, which is about average. So that to me means that the screen node is filtering correctly. And on the B+, we've got about 72 volts AC. So that would normally be about 4 or 5, depending on where the bias is at. Now the next thing to check, another weak spot in these, is the pissy resistors they use to balance the two caps. So essentially it's a voltage divider that makes sure that each cap shares the voltage pretty well equally. So on the negative, we should have about half of what we measure on the positive. And we don't. We've got nowhere near it. So those resistors go open circuit all the time, or very high in value. On the screen grid, it's not too bad, 218. But yeah, as a matter of course, I replace those balancing resistors, because almost every one of these that comes in, and every other Fender amp, because they all use the same type of resistors, they've either gone very high or completely open, and therefore the caps get exposed to more voltage than they should, which causes premature failure, which is likely what we've seen here. So if I take the negative off ground and just put it just across this one cap, we've got 353 volts DC, and that's only a 350 volt rated cap, and you should have at least 20% tolerance there. So likely one of those tiny, cheap, little shitty resistors that Fender uses has caused the cap to fail and caused the whole amp to fall over as a result. When will they learn? Never. So I've just unplugged and discharged everything. Now I'm going to give you a detailed look at what the previous tech's done and try and reverse engineer their thought patterns if there were any indeed. So essentially on these amps, if you want to convert them to adjustable, all you've got to do is lift one leg of R87 there and then insert a trim pot with the wiper on one end of the wafer into this hole and the other end onto the end of R87 or vice versa. Changing the value of R87 by the pot value or half the pot value will make the pot in its center travel be the same as if there was just R87 there. But you find these coming out very cold biased, so you often have to play with that value a little bit just to get it in the 50 to 60% range, which is optimal. But essentially all the other parts can remain. I suggest recapping it, particularly given the age of the unit. But the infrastructure, the board can be reused, all of that can remain, but just a slight modification and addition of one or two components in this position here. And you've got adjustable bias again. So what this tech decided to do instead was cut traces, run friggin' cloth wire everywhere, and then install this tag board down here, create a whole bias supply derived off the HT, which this one originally wasn't. You've got a low voltage tap there for a reason. Installed a pot which is accessible from the outside of the cabinet, which is risky because people reach in and play with stuff and you've just changed the bias point of the whole amp, threatening your output valves and other components in the amp. They've put a chassis mounted test point on there, which is actually testing across a 1 ohm resistor, which they've installed on only one of the valves. So you don't have a measurement for each or both of them combined. You've only got the single valve, which is kind of dumb because then you can't tell what balance it is. And there's no point doing that anyway, because any experienced tech would just do a output transformer primary resistance method of measurement without having to modify the amplifier. So just a closer look down here, you've got components passing over a melted mains lead, and that's the active there, and you've got the primary wire showing. So just a closer look, that's the mains fuse. You've got the active there, which is 240 volts. You've got melted insulation from work in this area, and I can actually see the wire there, so that's 240 volts exposed right next to all these clandestine components. That is very, very poor workmanship and poor safety. So I'm going to rip all of this out and do the more logical thing, which is replace that one resistor with a trim pot and a different value resistor. So one question I've got in my head about this this implementation was the tech just bored and he wanted to charge for doing all of this. He either knew that you could just replace that one resistor and chose not to for some reason, or he didn't know. And he decided to rebuild an entire bias supply unnecessarily and charge the customer for it. I don't know. I try to sort of be charitable in these cases and think maybe there was some reason for doing this, but you tell me, champions, there just doesn't seem to be any logic to this at all. Unless the customer specifically asked for this setup so it can be changed on the fly, on the road or whatever, and measured quickly. But you'd think you'd turn this the other way around so you can measure it from the outside of the amp, wouldn't you? There's just no logic at all here. I don't understand why these people do what they do. And it's incredibly frustrating because it just keeps happening over and over and over and over and over again. What could have been literally 1 minute more work when you're removing the board to address all the other stuff that should have been addressed in the first case and which has failed as a result of not being addressed. You could have charged nothing, like a couple of bucks to put a trim pot in. But you've got all of this drilling, custom layout, and then damage of the surrounding components from careless soldering. Anyway, let's move on. So the other thing the previous tech's overlooked here, and I do to every one of these that comes in, otherwise it bites me in the arse at a later date. I want amps to be reliable for their customers, and ideally I won't see another amp for a good 5-10 years until it needs another service, if it's taken care of. I like to replace all the plate load resistors because they love to go drift very high or go completely open circuit or get noisy. I don't know where Fender found these half-watt carbon films from, but they're very, very low quality and present lots of issues wherever they're used. And you can see the little balance resistors hiding down there. They're 220k instead of 100k like the plate loads, but same type of resistor, same brand, same line, and they love to fail as well, even though they're operating well within their specs. So obviously replacing all the IC axial caps. For some reason, their radial caps seem to be much higher quality. I've rarely seen any. I have seen it, but I've rarely seen failures of them. Whereas the axials just fail just by looking at them. So we'll replace them at the moment in Australia. The highest quality, best bang for buck ones are the Tube Amp Doctor Gold series axials, I believe they're called. So that's what I use. If anyone wants them, don't send me an email looking for them. Use Google, please. I don't have time to offer people personal Googling services, so just search for a product before you send an email, and I've got to stop doing what I'm doing and answer and copy links to you that you could have easily found online. Wagner Electronics in Australia, where you get them overseas, you'll probably have to get them directly from Tube Amp Doctor unless you have a regional dealer that does Tube Amp Doctor stuff. Another extremely well documented issue on these amps. Again, go check out my video which is dedicated to these amps. Some other techs around here could really do with watching that, I think. Replace these two diodes, not because they're faulty, but because they emit a lot of heat and they need to be lifted off the board to isolate the heat from the PCB. So obviously you can't do that with the existing length legs, and we're not going to do stupid shit like tack leads onto the existing component because it'll just desolder itself from them, given the heat. We're just going to put new diodes in there with longer leads that are kinked, providing that the pads underneath are in good condition. Otherwise you have to do things like install turrets to be able to mount them reliably, and then run wires to replace the damaged traces underneath from the heat. Same goes with these two resistors. These are chunky wire wound 330 ohms. I like to up them to 470, which Fender did in later years. It doesn't need to be that stiff, and it does slightly reduce the amount of heat emitted from them without affecting the regulation in a meaningful way. And lift them off the board, use lightweight V-shays. These are the ones I love. They're about half the mass of the original ones, and you can bend the leads very neatly and carefully using the kink pliers, the kinky pliers. Get them out on your nipples. But again, I'm like a broken record on this, so just go watch the video that I've referenced in the description, and I go over all this stuff in painful detail. I'm just going to dig in and get this thing sorted, replace some dodgy components on this board here. There's been some paralleling of resistors on both sides of the board to make up values because the previous tech could not be fucked doing a mouse order, I guess, or stocking a reasonable amount of parts. Very, very, very common value parts, I might add. But anyway, just things like the ribbons being pushed around in random positions. We'll clean all that up and optimize it for mitigation of like cross torque and oscillation, that kind of thing. The existing valves are testing up nicely matched. The next biggest concern with JJ's in particular is microphonics. So that one there sounds a bit clunky. That could have an effect on the signal, but we'll suss that out once we've got the amp up and running. And one other thing on this amp is we've got a dead reverb tank. It's a high impedance one, so 26 ohms is about right. But on the other coil, and I'm measuring on the actual pins there, the receiving coil is open circuit. Now, I have seen people repair these things, but it's very tricky, and it's probably temporary at best. It's easy to just replace them with a newer, higher quality tank. These are known to fail very commonly, as well as the Belton ones after it. I don't know what the deal is with this, if the previous tech threw this one in and maybe charged the customer. I don't know if he charged the customer for a new price and used one out of an existing amp. But anyway, this one's died a short term afterwards. Actually, I'm not even sure if they're supposed to be the same tank, are they? JCM 2000. Let me look it up. Okay, so I just looked it up, and all the impedances are correct, and it is a 2-spring tank. So internally it's exactly the same as the one that's meant for these amps, but it is designed to be in a vertical mounted position, not downwards. So you might find that the inner carriage will bash against the bottom of the bottom of the cabinet there, or the piece of cardboard inside the tank bag. Now the only thing that defines that is where the springs are mounted. See all these different holes there? So the different models of tank, the one to suit the hot rod Deville, they literally just put that spring in a different hole to make it so it's spaced differently. Because obviously that's mounted against the front panel in a JCM 2000 series head. But anyway, I've got the correct ones here because they do fail so often. So we'll pop one of them in there, and I've let the customer know that that requires replacing. Alright kiddies, don't try this at home, but one thing that happens when you lose your balanced resistors is you also lose the other name for them, the bleeder resistors. They don't bleed the caps, so the caps can sit there charged. Of course, there are very safe, very recommended ways of discharging these that are easy on the caps and safe for you to do. However, this is I'm a trained professional, and these caps are coming out anyway, so... Alright champions, just as predicted. We've got 3 out of 4 of these 220k balancing resistors are completely open circuit. So, you know, if it wasn't for all the non-series cap failures as well, I'd start to suspect that maybe the IC caps aren't as bad as we all make out. Maybe it's just the resistors failing, causing imbalanced voltages over spec, and then damaging the capacitors. But yeah, we see the 22 microfarad ones fail all the time as well. So I guess the lesson here is everything's shit. Yay! Alright, so here's a outside view of that test point. Normally they point outwards, but why would you put the adjustment facing... anyway, whatever. So this is the cathode current sense line coming out to the test point. You connect your other probe to ground, but again, it only tests one valve, so it's kind of useless. And although this is adjustable and accessible from the outside without opening anything, it is on the inside of the chassis, so you'd have to really do a reverse double Dutch rudder to get around to it. So, you know, we could be fine leaving all this in. Problem is now it's got my name on it, and this owner's going to go around telling everyone that I worked on this amp, and they're going to think this work's mine. So maybe I'll put a note in there, or you know what? I'm not real comfortable with having the mains input, the fuse there rubbing on the components and the tag board on the other side. Nothing should be touching the mains. It sort of kind of serves a purpose, but one that could have been solved by adding one component and not drilling any holes or running any wires or building any tag boards or having them rub against the mains fuse. So I don't know, I'm not comfortable with having it touching the mains fuse, particularly the active line there, and having a rub on that. You shouldn't have anything touching the primary if you can avoid it. Some grandfathered in designs you kind of can't avoid it without rebuilding and restructuring the whole thing, but this amplifier isn't one of them. So look, I could leave it in. It sort of kind of works, but I'm not comfortable leaving it in, particularly having my name on this amp now. Look, that's my reasoning behind it. I'm probably going to get comments saying I should have left it in. I'm not charging any extra to take this out. I just want to see it done properly and done how it should have been done in the first place, particularly because this is a good customer of mine, and he's going to go around telling everyone that I worked on this amp, and if anyone else looks inside it and sees that shit, they're going to assume it was me. Well, alright champions, so 99% of the work's done now. So we'll run over what I did and get this thing back together and start doing some testing before cleaning up the cabinet. It's seriously dusty. Hard soldering all the speaker connections, making a new speaker loom because those connectors always fail, and replacing the reverb tank. Besides all that, she's sweet as. Alright, so I've replaced the plate load resistors with my favourite GO carbon film half watters. I've reduced the bypass on the first stage to 2.2 microfarad. That cleans up the subharmonic and just very low frequencies that go through and swamp the next stages when you push the preamp quite a bit. This guy's primarily like a country player, so tightening up the bottom end really tightens up the lead tone, makes things a lot snappier. Through here we've got more of the plate loads replaced. Now up to the low voltage supply, you can see I replaced all the components here, lifted them off the board, got those lightweight V-shays and just some replacement Zenas there. They do emit quite a fair bit of heat, so lifting them off the board and just having the just the heat sink of the lead and just the isolation from that probably 3/4 of an inch of length. It just gives you a little bit of extra surface area and just pulls the heat source away from the solder joints in the board there. We've also used the forming pliers to make sure that I'm pointing right behind where there's a lead hiding it. Always. Camera Kung Fu. I've got to live for my game, champions. We've used the lead forming pliers, so it's got like a little foot there which mechanically holds the component against the board, so you're not relying on the solder pad on the other side to do all of the mechanical support. Replace the two caps here. Like I said, the IC caps that are radial, not the axial ones, tend to last a lot longer. They're actually pretty decent quality, but while we had the board out, we've upgraded it to Nichicon 105 degrees, Nichicon or Nippon Chemicon. Any of the cons are generally pretty good. Jamicon, it's ironic. Panasonic are also another brand of really good electrolytic caps. Worth Electronics is another one. Now, speaking of caps, I messed up and forgot to order more 100 microfarad 350 volters in the axial package, the tube amp doctors, to match these ones. However, I did have these ones in stock. These are on the Marshall boards that I make. They're very, very high quality, 10,000 hour Nichicon of the same value and voltage rating, 100 microfarad 350 volt, but they're radial. So what I've done, and I had these in stock because my man Rowan Diskin was kind enough to send me some of these radial to axial converters, the little circuit boards that you silicon to the cap, and then you silicon the whole lot to the actual board and put some little bus wires. Eventually we're going to have to use little boards like this for all vintage amps, because just the axials will be either prohibitively expensive or just completely unavailable. Particularly I'm finding that now in the low voltage ratings, like in the solid state amps like the Gallagher-Krugers and whatnot, which use like 63 or 100 volt caps in like 2200 or 4700 microfarad, that kind of value. Because there's so many vintage tube amps, valve amps we call them over here, that use axials, there are still companies making axials in the higher voltage ratings, but the lower voltages are seemingly the first to go, and it makes things like old solid state amps and even like computer restorations, vintage computer restorations, difficult. So little adapters like these will eventually be required for recapping older equipment. So you can check out Rowan's page. He runs Keld Amp Works in the UK. And he's also got a online little store where he sells all these handy bits and pieces called RSD Sounds, based in the UK as well. So check out the link down below. Go and support his business and tell him I sent ya. So that got us out of a pickle here. And cost-wise, it probably actually ended up being cheap because these caps are only a couple of bucks each, whereas because these are sort of like a legacy manufactured item, they tend to be a lot more expensive, and these are relatively cheap in the scheme of things. You can pay for a Sprague TVA Atom, you can spend 60 bucks on a single cap. It's fucking ridiculous, champions. So, and mind you, some of them are rated at like 65 degrees Celsius because they're a cap like this inside a large can for some stupid reason, for the vintage look, for the vintage fanboys. I really don't give a shit what your caps look like. I care about how they perform and how long they last and what they cost. I'll leave it to the Instagram boys. I do Instagram, but I tend to be more outcome driven than some of the other repair and manufacturing pages. Let's just leave it at that. So we'll look down here. Remember this? All this shit? All of this could be done away with by just doing this. So see, I've got a little resistor down there on the trim pot. Come in for a closer look. So that's a 10k trim pot and an 18k resistor, which should put us about, so when the pot's set halfway, should give us the stock value of the non-adjustable biasing circuit that was originally in this amp. So that'll allow us to go above or below that. We'll check the range and we'll just see that that's comfortable. So first guess, this would be, the logical value to have a good bias range, but we'll test with the valves and some reference sets that I've got here and just check that range is optimal. We've replaced all the bias supply caps and low voltage caps in that area as well. Just bringing everything up to the same standard. So just regarding this, I don't know if there's some reason that they didn't just do this simple mod down here, or if they were trying to stretch out the job in order to get a bigger invoice, more money. Because this is gilding the lily if I've ever seen it. Like, why create a whole power supply tapping off the high voltage feed? Like, why create this whole old school thing just to do what there's already infrastructure for in the amp? It doesn't make sense. I don't know. Like I say, trying to give repair guys the benefit of the doubt, because there may be stuff I don't know, but what possible reason could there be for doing this instead of just doing that? I don't know. If you can think of one, leave it in the comments, champions. Alright, so onto the output board. For some reason, as mentioned previously, they only installed a cathode resistor on one of the two valves. So if you're using the cathode current sense resistor measuring method to set the bias, you can only measure one valve out of two. So you'd have no idea if they were massively out of balance. So again, no logic there. So I was going to just do a bus wire there and save this socket, but I don't know. I wanted to just return it to... This is a really good customer of mine, so I want this thing to be rock solid, and I don't want to use hodgepodge parts. I want it to be a job I can be proud of. So I've decided to just go with new Beltons there. Replace both of them just so they match. And I've replaced the screen grids. We've upped them a little bit to 1K, 3 watt, as opposed to 470K, look like 2 watt. As you can see, that one's somewhat discolored. It's had a pretty tough life. Modern production valves, you gotta baby the screen grids a bit, because that's seems to be the first thing that fails. Now I replaced the bias feed, or I guess you could call them grid leaks, the 220K there, that they get fed the bias. You can see the trace through the board there, and then they go off to the 1.5K grid stoppers, and then to the grids. The main reason being that the pads were ripped on the bottom side, so I needed a new, longer wire on one of them to go over and hook it around this one, and then make its way off to the ribbon cable, because the previous tech had dodgily soldered wires to them and damaged the pads in the process of the existing resistors. So those resistors were okay, but I just needed a long lead on that one to be able to bring it over here instead of just dodging up a bit of bus wire. I thought I'll just replace them with some good quality metal film, Yagio's. As for the plate loads and the PI, there was tack soldered piggybacked resistors to try and get the values right. I just stocked the right values, mate. It's not that fucking hard. Got parts draws. He who dies with the most components wins. So they're one watt metal film. They'll have no sweat there. And up the back here, oh, focus test on old Sony boy. Hello. Focusing on the posts. Back there we've got two fusible metal film 100 ohms. If they do fail from a heated or high voltage short, they fail in a very graceful manner, rather than the carbon films which are in there before that aren't safety resistors. They flame up pretty good and damage the board. Plus just being 100 ohm, bit less load on the resistors there, generate less heat, less likely to fail, and plenty stiff enough to be able to give you a ground reference for the heater lines. Alright, champions, so I'm going to get this whole mess back together. Alright, champions, so I'm going to get this mess back together and run her up for a couple of hours before notifying the customer that she's ready for pickup. I'm not going to do sound samples on this one. You've heard this amp a million times before, or its brethren. But thanks for joining us, and just keep an eye out for dodgy work, and just be aware of what's required in these things. If yours does have issues, don't go to a tech that's got the blinkers on. Go to a tech that will look at the thing holistically and see all the other potential issues, because otherwise you'll just be going back to them every couple of months, as is the case with this one. They all seem to end up here, and then I don't see them for 10 years after that. And I sometimes get a bit paranoid. Oh shit, I hope they haven't gone to another tech. I hope nothing's gone wrong. And I eventually bump into them at a gig or something. I go, hey, yeah, how's that amp going from 10, 12, 15 years ago? They go, mate, it hasn't missed a fucking beat. So that makes me happy. It means I make less money, but it means my customers can keep doing their job of rocking out without getting their wallet out every month. Anyway, take it easy, legends. See you on the next one.